Hi everyone. Today we're going to learn a new idea in probability, and to do so we're going to take a look at this data set here. And in this data set you can see that we have people who've been asked their favorite sport, some like football, baseball, basketball, and soccer, but they're also broken down by two different age groups. And we could ask some basic questions like what's the probability someone likes baseball or someone likes soccer, or even what's the probability that someone's in the 15 to 25 age group. But I want to dig deeper to this age group. I want to compare perhaps the two different age groups and look at their preferences. And when we break down a population into subgroups and we start looking at the probabilities, this is a new idea that we're going to need, and it's called conditional probability. And we'll look at a few examples today. But first, let's do some basic ideas here and review here. For example, what's the probability someone likes baseball? Well, the probability someone likes baseball is 30 out of 110 because there were 110 total people in this survey. 30 of them like baseball, favorable over the total. And what's the probability that someone like football? Well, hopefully it's easy to see that the probability someone like football in this survey is 33 out of 110. There were 33 people who like football out of 110 people. But what if I want to break things down a little bit? What if I want to look at age 30 to 50 and how they like basketball versus age 15 to 25 and make some comparisons here? Well, that's the idea of conditional probability. We're going to compute and compare probabilities within subgroups. So let's look at some of these subgroups and what the probabilities are. So perhaps we want to compare the probability of basketball between the given age groups. So let's think here. Given that a subject is age 30 to 50, what is the probability they chose basketball? How would we do this question? Well, think about that first part of the sentence here. Given that a subject is age 30 to 50, that means for this question, I only want to look at people aged 30 to 50. So only look at this row here. In this row, how many people are there? There's 70. How many of them like basketball? There's 15. So the probability here is 15 over 70. So what we've done here is instead of looking at the whole population of 110 people in this survey, I'm breaking it down to just this subgroup of 70 people and finding an appropriate probability. Let's find another one here. Given that the subject is aged 15 to 25, what is the probability they chose basketball as their favorite sport? What constitutes the total? What constitutes the successes within that total? So here we're only looking at people aged 15 to 25. You see there are 40 people here. And within this subgroup, 14 of them chose basketball. So the probability is 14 over 40. Okay? So conditional probability really means instead of looking at the entire population, we're going to break things down into smaller groups. Sometimes that's called disaggregating the population. So here we have this long sentence to do the probability, but we also have symbols for this as well. We have symbols which communicate a conditional probability. Let's look at the two we just did. For example, we just found the probability that someone likes basketball given that they're age 30 to 50. So here, notice the symbols. That vertical bar, and it is a vertical bar, that means given that. So this means the probability someone likes basketball given that they are age 30 to 50 is 15 over 70. And I can turn that into a decimal if I want to. That's 0.214. How would I do it for the other question we did? What's the probability that someone chose basketball given that they're age 15 to 25? That was 14 out of 40. And I made that a decimal. And here it makes sense to make it a decimal because I want to do a direct comparison between these two things. Because I want the probability someone like basketball within each of the groups. And here I can now see that basketball appears to me be more likely within the age 15 to 25 age group as compared to the age 30 to 50 age group. And that wasn't clearly evident because if you look at the table, the number of people who chose basketball was higher in the age 30 to 50 age group. But because we asked so many more people in that group, the fact that the popularity is actually bigger within the younger group is lost a little bit. So breaking things down here can be very helpful. Now that symbol can be a little bit goofy here, but in general it means that the probability of A given B is the probability of event A given that event B is true. Okay? So notice that the thing after the capital letter P, that's the probability we seek. And the thing after the bar is the condition we're placing upon it. And notice that bar is a vertical bar. It is not a fraction bar, it's a vertical bar. Okay? Let's do a couple more here. Let's try this one. What is the probability that someone is age 30 to 50 given that they like soccer? Okay. How have we split up the population? We do want the probability someone is aged 30 to 50, but I only want to look at soccer players. So here's my sample space for this problem. It's only the soccer players. There's 18 of them. 5 of them are in that correct group. So it's 5 out of 18. Okay. We can even extend beyond the table here. Let's try one about a deck of cards. A card is drawn from a deck of cards. Given that the card drawn is red, what is the probability it's a heart? Okay. How many cards make up our sample space? Well, the card is red, so we're no longer looking at all 52 cards. We're only looking at the 26 red cards. Within that group, how many hearts are there? We can see here the probability of drawing a heart, given that the card is red, is 13 over 26, which is 1/2. It makes sense to reduce things when it's a nice reducing, right? So conditional probability means taking the population, dividing into subgroups.